This week we're talking about the different observations that go into making a forecast and how to make a forecast. So basically, we're combining everything we've learned. So I thought, well, let's just look at what the weather is right now and how it may progress into the next couple of days. So we're going to start just simply looking at a satellite image. It's a great place to start. I like to start with satellite all the time when I was forecasting because you see a lot of information. First off, what I'm seeing here is a closed upper low with a nice comma head to the low at the surface and stuff. So there's a well uh, extratropical cyclone in here. Notice the moisture along this front coming up into it. You can even track some of that moisture all the way into the southern Pacific. And then there's lots and lots and lots of thunderstorms off of the Gulf Coast of Florida and lots of clouds out ahead of this system. And it doesn't seem to be moving very fast. It looks like this thing sitting there. So maybe I want to learn a little more about what's going on. So with that in mind, there are a couple of channels we could look at. Say I wanted to know if there was any lightning going on right now. See if there's any instability out there that way. So let's take a look at the lightning. And immediately, I'm seeing lightning over a southern part of Ohio, here in parts of Kentucky, Tennessee. Lots and lots and lots of lightning down here in Florida and off the coast here. So yes, there is some instability in here. And this is fairly early in the day. We're not much after 1 o'clock here. Maybe I want to learn a little bit about moisture. So let's take a look at some moisture channels here. One of the water vapor channels, mid-level, is one I would like to use normally. And I can immediately see we have a very wrapped up system here. And yet we have a lot of moisture coming out of the Gulf and from the Pacific and in and around to it. So there is a good area of moisture setting up over the eastern part of the United States here as the system slowly drifts east. So this is our weather maker. If I'm in Ohio, I am concerned about this weather. This is what's going to be influencing me. And you'll notice there's drier air in here. What happens is with systems like this, they mix in some stratospheric air into them, which actually, as the jet stream and all, can show the jet, but it also can show some of the drier area mixing in from the stratosphere. So now we've looked at weather from perspective of on high, shall we say, up looking from the satellite. Let's go looking at a little lower. Well, there's that low we were talking about, and it's actually a occluded low, just like we've learned about the occluded fronts. And this is a cold occlusion. And notice, warm front here, plenty of moisture, 77-degree dew point here. Lots and lots of moisture coming up out of the Gulf. Drier up in here, and on the west side of it, temperatures are a little bit cooler. So we can actually track that front. Go back 12 hours, and we can see, well, the low is just, getting going there in Iowa, Illinois. And 12 hours later, it's hardly moved. So the front has moved, but the rest hasn't. So if you're in Ohio, we know we're getting moisture coming up well over this warm front here. We know we have an upper level system there. And we know we have an occluded, very slow moving upper low pressure system at the surface here. So now let's look a little bit of loft. Let's go to 500 millibars. Well, here it is. That low is right underneath the upper low. So perfect example of a cold core system. Out in the west where it's been so hot, notice the big high pressure, 601. Wow, that's really a high for this time, even for this time of year. So that's why it's so hot out here. And we can see winds are still stronger on the west side of this low coming into it. So there's momentum coming in compared to going out. So this actually will probably continue to drop southward and not move east really fast. May even get a little more. So you can tell that from just looking at 500, seeing the winds. We talked about the winds and how strong they can be and all. So this is a great example of looking at some of the jet there. Now, if I want to look at 850, the green lines are going to be moisture. We can see lots of moisture shooting up from the Gulf. We can see a closed circulation. So what we're actually noticing here is everywhere east of this is gradually going to get more and more moisture. Everywhere west on this, cooling down and less moisture. So everything I need to know is getting concentrated right in here. And if, for example, I wanted to take a look at a sounding, say from Cincinnati, which is just on the edge of this moisture right now, and we can see here moisture in the mid levels, moisture in the high levels, a couple dry spots here and here. High means that maybe a few breaks in the clouds, and instability here a little bit, especially if it were to warm up some, but not a lot. It's just kind of a very, very warm, humid sounding. So while it may get some thunder with it, it's not really a sounding that is conducive for tremendous thunderstorms in this section at this time. There are some areas out here where they're actually talking about severe weather. And we can see here much more instability, and we have some wind shear as well. So now we've talked about what is going on. We've actually learned a little bit about that. So what's going to happen with it? Well, I'm going to look a little bit at numerical guidance. All right. These are all models generated by the National Weather Service. I'm not looking at the European model. You can find it if you really want, but I figured we could just start looking at the U.S. model. So we'll take a look at the GFS, which is a Global Forecast Systems model. I'm going to deal with the CONUS, and we're going to keep it simple. We're going to go 72 hours out, and we're going to look just at 850 temperature, mean sea level pressure, and precipitation, which is a 3 or 12-hour total. And I am just going to loop 3 days of this, which would be 72 hours. And we notice there's that low that we saw in Illinois and Indiana. And all we're seeing is, look, here's this warm front that's coming north into Ohio. And we just see lots and lots of precipitation here. That low just weakens with time, kind of eventually moves east of the area, but not until Monday afternoon. So we have all day Sunday and much of Monday in that precipitation. And the eastern there, here's your new low developed up here. We have the cold front that's going down through here. So that low moves from here to here in 72 hours. So not the fastest. Plenty of precip. You can see some spots down in Florida that has some big ones. Some other ones out here. Here's a good area of heavier precip developing. Side of the mountains. There's some up in here as well. We can literally almost see the low gradually moving up with time here in the cold front stretching south. Plenty of precip along the east coast at times. And that cold front almost stalls out. Look at that. There's only a 10-16, 7-17 high here. The high is not very strong. So that is the way we look at these numerical models sometimes, because we want to get the information we can from them. I just keeping it simple with this. Let's take a look at a different one. So we'll look at a different model now. I'm going to look at the North American model, which is a high resolution model, where this is a little broader resolution, covers the globe. This, you can see, has very limited area. So that means there's boundary conditions which have to be dealt with, which means we're bringing in things from this model into this model. But the idea is hopefully that mostly we'll be able to reconcile that. So let's take a look at this over the Great Lakes. I think there's one here I saw somewhere. U.S. Northeast would work. So we'll take that. High res. And again, we're just going to look at 850 millibar. mean sea level pressure at the surface. And that. Okay, this model only goes to 60 hours. So we're dealing with shorter range. So let's loop it and see what we get. Here's your low, moving these. This picks up some higher precipitation totals coming in. Here's your low moving slowly, and it's still moving slowly. Notice all these bands of precipitation developing on the East Coast. Here's the made a little bit further east, and we finally get it moving up into New England here at the end of the season. What this gives you is a much higher resolution graphic. We didn't see these, oh, this is a pretty heavy precip, or, oh, look at all these thunderstorms that probably developed along this, that developed this precip with the other model. We even got it on the East Coast here along the sea breeze front and coming up there. Some over my house's area there. So this model is much better at picking out details. The other one gives you a general overview, and sometimes they're different. They're going to come up different. But this time they look pretty similar. The track of the low is very similar. This is just adding the ability to pick thunderstorms. The other model did not have the ability to identify thunderstorms either. This one does. We could infer thunderstorms. So as you can see, we can really learn a lot from these. Finally, I just wanted to go back. And there are things called ensemble models. And we can look at those. What they are is we take a surface condition, the best surface condition we got, and then we do statistics to vary that surface initial conditions so that they actually supposedly will encompass almost all possible initial conditions where we may have had an instrument go bad, or maybe we're not picking up enough information. We want to do that so we can get what they call an ensemble. Also, since the equations can't be solved perfectly, we do a little bit more with them as well. And we're going to look at big picture here a little bit. And we'll just do 3 days. And you can see it picks up the, look at how it's not really picking up well. It's really getting pretty noisy up in here at the end. Yes, there's a upper level low in this area, but I couldn't tell you where it exactly is. It's a large spread. I can go back and look at a different sample. Maybe we can get a little lower. And we'll see what this does. There we go. What I notice is it kind of shows it weakening on one of them, but here you can see it pretty clearly. And then it just, further out it gets, the more noisy it gets, and the more there's a general low up in New England, but not so much in the United States, this part of the United States. So this is how we can see how difficult the forecast may be, how much it may be off by, and learn some things about it with using these ensembles as well, knowing that our forecast may not be perfect. We can also use statistics, and there are statistical models that will tell you temperatures, that'll tell you the probability of precipitation. It's all based on these. So hope you get a little bit out of all of this course. Again, let me know if you have any questions.